Hello, everyone. Welcome back for another math lesson with Mr. Hopkins. Today we're looking at lesson 3-4. We're factoring the difference of two perfect squares. So first, let's get after it by listing all the perfect squares up to, let's go to 225, which is 15 times 15. So first of all, the perfect squares. We have 1, because 1 times 1. 2 times 2 is 4, making 4 a perfect square. 3 times 3 is 9. 4 times 4 is 16. And we've got 25. 6 times 6 is 36. 49. 81. 100. 11 times 11 is 121. 12 times 12 is 144. 169. 196. And then we have 15 times 15 is 225. So let's make sure I didn't skip one. 1, 2, 3, 4, 5, 6, 13, 14, 15. It looks like we're good. Okay, so the steps when we are factoring the difference of two perfect squares. Well, first of all, they're going to look like this, where it is a binomial, where they are both perfect squares. If I have an exponent, it has to be even, and the number has to be a perfect square. Most importantly, it has to be separated by a minus sign. Otherwise, it's not a perfect square, and chances are it is not factorable. Okay, so the steps would be to take the square root of each piece. So we can just say square root each part. And then we have two sets of parentheses. And inside those parentheses, one will be separated by a positive, one will be separated by a minus. It's as simple as that. So we've already done the hard part. And I will show you why in just a moment. Okay, so the first term we already know, y times y gives me the y squared. So what are the factors of 36? Well, the square root of 36 is 6 times 6. Essentially, I'm doing the same thing that we did in the previous lesson, only the middle term is 0. It's like saying y squared plus 0y minus 36. So the factors of 36 that add to get 0 would be plus 6 minus 6. They add to get 0, which is really the middle term. It's not there. So they have to cancel. That's why we take the square root of them, and we say it's the difference of two perfect squares. So plus 6 minus 6. And you can write those in either order. Does not matter. This next one then. It's going to be m and m. The square root of 144 we know is 12. Since it's separated by a minus sign, it's plus 12 minus 12. The next one, 9x squared minus 4. Looks a little different, but it's not. Let's see if this catches my pen. There we go. 3x times 3x equals 9x squared. So 3 times 3 is 9, x times x is x squared. 4 goes to plus 2 and minus 2. Let's see if this pen keeps freezing. Oof. A little much there, a little much. Let's see this. There we go. So I said plus 2, minus 2. Thank you for your patience on that. This next one here, a to the 10th minus 121. So remember, when I take the square root of a variable, what I do is I cut that in half. Now, we didn't know that yet, but we know the other side of it if I was to multiply. So this is giving me a little trouble here, freezing up. Okay, let's try this again. So if I cut that 10 in half, a to the 5th times a to the 5th. Because when I multiply exponents with the same base, I add them. So 5 plus 5 would give me the 10. So the square root of 121 is 11. So I have plus 11 and minus 11. Let's look at a couple more. M to the 8th plus 16. Since that's separated by a plus sign, I cannot factor it. This is as far as I can go. Kind of a trick question. So let's move on to the next one. Be sure, is 81 x to the 4th a perfect square? The answer is yes. Is 25y squared a perfect square? Also yes. And the last thing that has to happen is it's separated by a minus sign. So if all those are true, then I can factor it. So the square root of 81 we know is 9. Half of x to the 4th is x squared. So we have 9x squared times 9x squared. Then 9 times 9 gives me 81. X squared times x squared gives me x to the 4th. Since it's separated by a minus, one is positive, one is negative. The square root of 25y squared is 5y times 5y. Okay, a few more to go. 4 minus x squared. Yes, both parts are perfect squares. It's separated by a minus. So 2 times 2, x times x. One's positive, one's negative. Over here, ask yourself, is c to the 20th a perfect square? It's an even exponent, so the answer is yes. 4/9, is that a perfect square? Still yes, because 4 is a perfect square and 9 is a perfect square. And it's separated by a minus. So we've got c to the 10th times c to the 10th. We have plus 2/3 minus 2/3. X to the 15th, is that a perfect square? No. Trying to trick you again. Cannot factor it. And these two here. W squared over 16. Perfect square. I like it. 81 over 100. Same thing, and it's separated by a minus. So let's factor it. W over 4. Google is struggling on saving my changes right now, so let's bear with me. Bear with Google. Cami. Not sure who's in charge here. Still saving changes. Come on, Cammy. Here we go. Okay, so that's W over 4 times W over 4. One's positive, one's negative, and then 81 over 100 goes to 9 over 10. Okay, so I hope you didn't find this too difficult. If you have any questions, please reach out. There is some practice examples attached. Let's see how you do, and I'll post an answer key shortly. Enjoy.